I'm about 2 weeks into doing my first project for the Raspberry Pi Pico, and I'm going to explain why I was wrong about the Raspberry Pi Pico. So when the Raspberry Pi Pico came out, the year I was using the ESP32, and I was about a few months into doing a project for that. And I thought, oh well, the ESP32, that's got kind of everything. It's such a powerful thing for a microcontroller that it will become my standard microcontroller for doing projects. But I was actually wrong about that, and in this video I'll show you how far I am through the current project that I've got for the Raspberry Pi Pico, and I'll take you through that actual project and explain why actually the Raspberry Pi Pico is a lot better than I thought it was. Because initially I watched the Raspberry Pi video that the Raspberry Pi Foundation came out with, and they explained all the hardware, and I thought, well, comparing that to an ESP32, the ESP32's actually got a bit more hardware, like a bit more RAM, it's got the Wi-Fi on it. And I was thinking, well, the Raspberry Pi Pico, it's not that far behind, but it's not so much RAM, and so really, why would I use a Raspberry Pi Pico when I could just use like an ESP32? So in order to demonstrate why I was so impressed with the Raspberry Pi Pico, that actually it's probably going to become my default microcontroller over and above the ESP32. I turn on my monitor in the background, so I've got the monitor connected over VGA, so I've got some VGA signals coming out of my Raspberry Pi here. And if I plug in my Raspberry Pi to the power supply, let the monitor sync up. So it's actually driving the VGA display in the background. So if I just go on to the next screen, so it's actually rendering all of this, the Pico is doing. And if you saw how quickly that rendered, I mean, all of these characters are individual characters being rendered as a character string. Character strings, and all of these dialogues actually polygons being rendered and filled as well. And that's all being done by the Raspberry Pi Pico. And that's been done by mostly the PIO, which is the programmable peripheral interface, which is in the Raspberry Pi Pico, which is separate from the CPU cores, and it uses DMA as well to transfer information between RAM and the actual Raspberry Pi Pico itself through the programmable peripheral interface. So actually, I'm currently barely touching the CPU cores. So there's two CPU cores on there. Both of 125 megahertz by default, but actually all of the work for displaying this display is done by the Raspberry Pi PIO, which is a programmable interface for peripherals, and so that's doing all the scanning for the VGA, and it's taking the memory from the RAM and displaying it up on the display, and it's using DMA to do that. So that's why it's so fast to do refreshes, and also the actual rendering is happening very fast as well, because it's using DMA to move memory between RAM to RAM. So like I say, that's barely touched in this. I'm not using the CPUs at all at the minute. So my application now has all of the CPUs to itself, and the VGA isn't actually affecting the application that I've got run, or that I will have running on the Raspberry Pi Pico. So if I go to the next screen, and so this is, I've got 8-bit color, so I've got 255 colors, which you can see there. And again, when I press the button, you see how quickly it refreshes, and that's the 255 color picked photograph which I've put onto there, all being rendered from the flash ROM straight into the RAM, the video RAM. So that's the DMA doing that, which is why it comes up so quickly. And so I go on to the next picture. See how that's so amazing. I was incredibly impressed when I saw that. And so the Raspberry Pi Pico, one of the best features is the PIO plus the DMA. So the PIO can actually control peripherals at 125 megahertz. So each instruction in the PIO, you've got 64 instructions, so 2 lots of 32 instructions in the PIO, which you can do whatever you want for peripherals. And then the DMA in the Pico, you can transfer data from any peripheral to RAM, from RAM to any peripheral, and from flash memory to peripherals as well, or flash memory to RAM, which I'm doing in this case as well. So if I go on to the next one, and so in my application, I've currently got a bunch of fonts from 8-bit computers. This isn't IBM 850. I've got to put that font in there because that will be my default font for my terminal. But I'm currently just using the Spectrum one in there because the Spectrum one is ASCII compatible. So at the minute I'm rendering all of the other displays from the Spectrum character set. I've got the Jupiter Ace character set, the Commodore PETSCII character set, and the PETSCII shifted character set. And I've got, this will be user defined, ZX80 character set and ZX81 character set. So where I've got emulators which emulate ZX80 and ZX81 and display on terminals, and I've so far had to display kind of approximations of these graphics characters from the IBM 850 character set. But now, hopefully, when I use my project, which will be a terminal using this Raspberry Pi Pico, it'll be able to actually use the character set which was in the ZX81 and ZX80, and so it actually looked like ZX81 and ZX81 games. And then I've got the ZX Spectrum character set at the end as well, because I thought, well, why not just all these character sets are available in the ROM images, so just like lift them off of there and I can use them for free. Then I don't have to design them. When I design character sets, they don't always look brilliant, but if you just like take the ones out of the 8-bit computers, then they look like the 8-bit computers then. So I just go on to the next one. So that's just rotating back through the screens again. So my application, the next thing I've got to do, which is the other thing which is fantastic about the Raspberry Pi Pico, is the USB interface. That can be used as a host or a device. So I'm hoping to use that as a host and be a host for a USB keyboard, which will complete the hardware for this terminal emulator, because I'll have input as a USB keyboard, a VGA display output, and then you've got the standard UART interfaces, which I can connect a UART interface to my 8-bit computer or any other kind of device which uses a terminal. But my 8-bit computer is the target for this, which is why I've got all of the character sets, so I can make use of those.